In this video, we're going to take a look at finding the nth term of a quadratic sequence. So what I've been given here is the first 4 terms of a quadratic sequence, and I want to show that the nth term is given by this quadratic here. Now, just recall to begin with here that the nth term of a quadratic sequence, so the nth term is given as an squared, so an squared plus bn plus c. Okay? So how do we find the nth term here? Well, the first thing I'm going to do is find the difference between each term. Okay, so from -5 to -3, that's a difference of 2. From -3 to 1, that's a difference of 4. And from 1 to 7, that's a difference of 6. Okay. Now, for an arithmetic sequence, that's all we have to do. But for a quadratic sequence, we now need to find the difference of these differences here. Okay. So from 2 to 4, that's a difference of 2. From 4 to 6, again, that's a difference of 2. And so on. So what you should find then is when you calculate the second lot of differences, they will all be the same value. Okay, so I get 2, 2, and I would get 2 again for the next term, and so on. Okay. Now, we just need to do something with this 2 here to give us a. So a, in this case, is equal to this value here, so the difference of the differences, and we divide that by 2. So in this case, a will be equal to 2 divided by 2, which will give me 1 there. Okay. In that case, my nth term now, so if we do that over here, so my nth term here will actually begin as n squared, and be n squared here because a is 1, plus bn plus c. Okay. So how do we now find b and c here? Because we've already worked out a is 1, and we can see that here. We now need to find b and c. But what I'm going to do now is use the fact that I can find my, or use my nth term here to find any term in the sequence. So for example, when n equals 1, the nth term here will be -5. Okay, so my first term in the sequence is -5. So what I'm going to do now is substitute n equals 1 in, set that equal to -5, and then we'll do the same with another term. For example, n equals 2 there, and we'll set that equal to -3 because we know the second term here is equal to -3. And what that will give us then is some simultaneous equations. We can then solve them to find b and c. Okay, when n equals 1, I'm going to get 1 squared. I get 1 squared plus b lots of n. So if n is 1, that's just plus b. And we've got plus c, and that's all equal to -5. Okay, so that's equal to -5. So if I just simplify this here, I've got 1 plus b plus c. So I need to subtract 1 off both sides. So I get b plus c is equal to -6. Okay, so b plus c is equal to -6, and we'll call that equation 1. I'm now going to do the same here for when n equals 2. So when n equals 2 here, in that case, we're going to get 2 squared. And then I'm going to get bn, so if n is 2, that's 2b plus c, and that is equal to -3. Okay. So again, now let's just simplify here. This is going to be 4, so I get 4 plus 2b plus c is equal to -3. So what I need to do now is subtract 4 off both sides, so I'm going to get 2b plus c is equal to -7. Okay. What I'm going to do here is call this equation 2. So what I've got now is simultaneous equations here. So let's just clear the top side of the screen here. Let's just clear up here. Go to our nth term as well. Let's just clear this so we don't cause confusion. So let's put our simultaneous equations together here. So I've got b plus c is equal to -6. I've then got 2b plus c is equal to -7. So 2b plus c is equal to -7. So from here now we just need to solve these simultaneous equations. What I notice straight away is the coefficient of c here is the same. That's both just 1c there. So in that case we can use das now. So remember, if the sign is different, we need to add. If it's the same, we subtract. Okay. So what would that give us here? So b minus 2b. So b minus 2b, that would give me minus b there. I've then got c minus c. So c minus c, they just cancel. And then I've got minus 6 minus minus 7. So do take care there. So minus 6 minus minus 7, that's the same as minus 6 plus 7 there, which would give me 1. So I get that minus b is equal to 1. In that case, then, if I want b here, that would simply be minus 1. Okay. And that matches what we've got here for our nth term. That should be minus m. So that would be correct here. And all we need now is c. So in that case, I can just substitute this back into either of these equations. It makes sense to put it back into the top one here. So b plus c, so if b is minus 1, that's minus 1 plus c is equal to minus 6. Add 1 to both sides here to balance the equation. And what I'm going to get then is c is equal to minus 5 there. Okay. So notice now we've got n squared minus n minus 5 as our nth term. We've already evaluated that a is 1. Okay, we did that here. We've then found that b is equal to minus 1 and c is equal to minus 5. So therefore, let's do this in a different colour here. So therefore, my nth term here is given as an squared, where a is 1, so that's going to be n squared, plus bn. So if b is minus 1, that's going to be minus n. And then finally, c is equal to minus 5, it's plus c, that's just the same as minus 5 there. Okay, so our m term is equal to n squared minus n minus 5 as required there. Okay. And there we have it. So that's our solution to question 1. Taking a look at one more question here to finish with. If you do feel confident enough, pause the video now, have a quick look at this question. But if not, let's take a look together. What I've been given here is the first 5 terms of a quadratic sequence. Now we're asked to find an expression in terms of n for the nth term of this sequence. And remember, for a quadratic sequence like this, the nth term is given as an squared plus bn plus c. Okay? So what I need to do here is find the difference between each term to begin with. So from 5 to 11, what I'll do is I'll actually write these underneath. So 5, 11, 21, 35, and 53. So from 5 to 11, that's a difference of 6. From 11 to 21, that's a difference of 10. From 21 to 35, that's a difference of 14. And then from 35 to 53, that's a difference of 18. Okay? And remember, we don't finish there with the differences. What I need to do now is calculate the difference of the differences. So a bit of a tongue twister. So from 6 to 10, that's a difference of 4. From 10 to 14, that's also a difference of 4. And from 14 to 18, again, that is a difference of 4. Okay, notice these differences here are all the same, which is good. That's what we should get. Okay. So from here now, this gives us a here. Okay, remember, all I need to do now is divide this by 2. In that case, a is equal to 4 divided by 2, which gives me 2. Okay, so I can now update the nth term here. So my nth term here is equal to 2n squared plus bn plus c there. Okay. Now what I'm going to do here is substitute n equals 1, n equals 2 into my nth term here. We know what the nth term will be because we know what those terms will be. So it's going to be 5 and 11 for my first 2 terms. What I can do then is form simultaneous equations. Okay. So when n equals 1 here, when n is equal to 1, I'm going to get 2 lots of 1 squares, so that's 2, plus bn, so that's going to be plus b, then plus c, and that is going to be equal to 5, okay? Because when n is equal to 1, that gives us the first term in the sequence, so we know that's going to be equal to 5. We now do the same with n equals 2, but before we do that, let's just simplify this equation here. So subtract 2 off both sides. I'm going to get b plus c is equal to 3. Okay. Do the same now for when n is equal to 2. So substituting n equals 2 into our nth term here, I'm going to get 2 lots of n squared. So n squared here would be 2 squared, which would be 4. So times that by 2, I'm going to get 8. You then get bn. So if n is 2, that's 2b plus c, and we know the second term here in our sequence is equal to 11. Okay, that's equal to 11. Again, simplifying this here, subtract a off both sides and I get 2b plus c is equal to 3. Okay, so if I call this equation 1 here, I call this equation 2, then I can form my simultaneous equations. Okay, so let's do this in a different pen colour, do it in orange. So what I've got now is b plus c is equal to 3. And then I've also got 2b plus c is equal to 3. Okay. Now again, notice that the coefficient here, the number in front of c, is the same for both of these. It's just 1 again. So remember das here, if they're different you add, if they're the same we subtract. Okay, so I'm going to subtract here. So b minus 2b, that would give me minus b. The c's will cancel here, so c minus c, that's just 0. And then I've got 3 minus 3. So what that gives me then is minus b is equal to 0, which in that case would also mean that b is equal to 0. Okay. We've got that b is equal to 0. I just want to find c now. So in that case, just substitute that into either of these equations here. In this case, I think it's easy to just substitute into equation 1. So in that case, 0 plus c is equal to 3, which in that case means that c is equal to 3. Okay. So what I need to do now is just substitute that back into my m term here for a, b, and c. So in that case then, my m term here is going to be equal to an squared. So we worked out a was 2, so I get 2n squared. We've got that b is 0, so that's going to be 0n, so we don't need to put that term there, that will just disappear. And then I've got plus c here, which is 3. So my m term here is 2n squared plus 3. Okay, and notice that's our solution there. So I'll just highlight that. That gives us our solution. Now remember, you can verify your solution here for the nth term. Just substitute n equals 1, n equals 2, n equals 3. So when n equals 1, you should get 5. When n equals 2, you should get 11. You should get 11, and so on. Okay, so you can double check that and make sure that your m term gives you the correct solution there. But there we have it, so that gives us our solution to that question, and that brings us to the end of this video on finding the nth term for a quadratic sequence. In the next video, we're going to take a look at exam revision for a quadratic sequence.